A number 6 copper bonding conductor is an acceptable grounding electrode conductor for a telephone board. It should be connected directly to the grounding electrode system of the building, such as the main ground rod or the building's electrical service panel. The number 6 bonding conductor can be routed through the same raceway as the telephone cables, provided that the following conditions are met. Firstly, the raceway is metallic and permanently grounded. Secondly, the bonding conductor is protected from damage by insulation or other means. Thirdly, the grounding electrode system is accessible and maintained in accordance with the National Electrical Code. Since the building is an old concrete structure with no exposed building steel, the building steel cannot be used as a grounding electrode. The grounding installation for the telephone board appears to meet the requirements of the NEC and should provide adequate protection against electrical hazards. When grounding a telephone board, several factors must be considered to ensure safety and compliance with the National Electrical Code. The primary purpose of grounding is to provide a low impedance path for fault current to return to the source, thereby tripping a circuit breaker or fuse and preventing electrical shock hazards. The size of the grounding electrode conductor is crucial. According to the NEC, a number 6 copper conductor is generally acceptable for grounding a telephone board. However, it's important to consult the specific requirements outlined in NEC section 250.66, which details the sizing of grounding electrode conductors based on the size of the service entrance conductors. The grounding electrode conductor should connect directly to the building's grounding electrode system. This system typically includes a ground rod, a metal underground water pipe, or a concrete encased electrode, often referred to as a U for ground. The connection point should be accessible for inspection and maintenance. If the building has a main electrical service panel, the grounding electrode conductor can be connected to the grounding busbar within that panel. Routing the grounding electrode conductor through the same raceway as the telephone cables is permissible under certain conditions. The NEC allows this practice as long as the raceway is metallic and is itself properly grounded. This ensures that the raceway provides an additional layer of protection for the conductors within. The bonding conductor must be protected from physical damage. This can be achieved by using insulated conductors or by ensuring that the raceway provides adequate protection. The NEC also requires that the grounding electrode system be accessible and maintained in accordance with its guidelines. This means that the grounding connections should be periodically inspected to ensure they are secure and free from corrosion. If the building is an older concrete structure without exposed building steel, the building steel cannot be used as a grounding electrode. In such cases, alternative grounding electrodes, such as ground rods or concrete encased electrodes, must be used. Ground rods should be at least 8 feet long and driven into the ground until at least 8 feet of contact with the soil is established. Concrete encased electrodes, if present, must meet the requirements outlined in NEC section 250.52. It's important to note that the grounding requirements for telephone systems are distinct from the grounding requirements for electrical power systems. While both serve to protect against electrical hazards, the specific requirements and methods may differ. For example, telephone systems often require additional surge protection devices to protect against lightning strikes and other transient voltages. The NEC provides detailed guidance on the installation of these devices. In summary, grounding a telephone board involves selecting the appropriate size of grounding electrode conductor, connecting it to the building's grounding electrode system, ensuring that the raceway is properly grounded, protecting the conductor from physical damage, and maintaining the grounding system in accordance with the NEC. By following these guidelines, the telephone system can be effectively grounded, protecting against electrical hazards and ensuring safe operation. Several specific NEC sections are relevant to this discussion. NEC section 250.4 outlines the general requirements for grounding and bonding. NEC section 250.50 discusses the grounding electrode system. NEC section 250.66 details the sizing of grounding electrode conductors. NEC section 800 covers the specific requirements for communications circuits, including telephone systems. Understanding these sections is essential for ensuring compliance with the NEC. In addition to the NEC, local codes and regulations may also apply. It's important to consult with local authorities to ensure that the installation meets all applicable requirements. A proper grounding system not only protects against electrical shock hazards, but also helps to minimize electrical noise and interference, which can degrade the performance of the telephone system. By providing a low impedance path for fault current, the grounding system helps to ensure that the telephone system operates reliably and safely. Choice of grounding electrode conductor material is also important. Copper is the most commonly used material due to its excellent conductivity and resistance to corrosion. However, other materials, such as aluminum, may be used under certain conditions. The NEC specifies the requirements for these alternative materials. When installing the grounding electrode conductor, it's important to avoid sharp bends or kinks which can increase the impedance of the conductor. The conductor should be installed in a straight and direct path as possible. The connections to the grounding electrode system and the telephone board should be made using approved connectors and methods. These connections should be tight and secure to ensure a reliable electrical connection. Regular inspections of the grounding system are essential to ensure that it remains effective over time. These inspections should include checking the condition of the grounding electrode conductor, the connections, and the grounding electrodes. Any signs of corrosion or damage should be addressed promptly. If the building undergoes any modifications or renovations, the grounding system should be reevaluated to ensure that it still meets the current requirements. This is particularly important if the electrical service is upgraded or if new equipment is added to the telephone system. The use of surge protection devices is highly recommended for telephone systems. These devices help to protect against voltage spikes caused by lightning strikes or other transient events. Surge protection devices should be installed at the point where the telephone lines enter the building and at the telephone board itself. The grounding of surge protection devices is critical to their effectiveness. These devices should be connected to the grounding electrode system using a short, direct path. The NEC provides detailed guidance on the installation and grounding of surge protection devices. In summary, grounding a telephone board is a critical aspect of electrical safety. By following the guidelines outlined in the NEC and consulting with local authorities, it's possible to ensure that the telephone system is properly grounded, protecting against electrical hazards and ensuring safe and reliable operation. The selection of the correct components, the proper installation techniques, and the regular maintenance of the grounding system are all essential to achieving this goal. Furthermore, consider the specific environment in which the telephone board is installed. In damp or corrosive environments, special precautions may be necessary to protect the grounding connections from corrosion. This may involve using corrosion-resistant connectors or applying a protective coating to the connections. It is also important to consider the potential for electromagnetic interference. In areas with high levels of electromagnetic noise, shielded cables and connectors may be necessary to prevent interference with the telephone system. The grounding system can also play a role in reducing electromagnetic interference by providing a low impedance path for noise currents to return to the source. When routing the grounding electrode conductor, avoid running it near sources of electromagnetic interference such as power cables or transformers. If it is necessary to run the conductor near these sources, use shielded cable or conduit to protect it from interference. The NEC also addresses the issue of grounding multiple buildings or structures that are supplied by the same electrical service. In these cases, it is important to ensure that the grounding systems of the different buildings are properly interconnected. This can be achieved by using a common grounding electrode system or by bonding the grounding systems of the different buildings together. The NEC provides detailed guidance on the requirements for grounding multiple buildings. In addition to the technical aspects of grounding, it is also important to consider the administrative aspects. Ensure that all grounding work is performed by qualified and experienced electricians who are familiar with the NEC and local codes. Keep accurate records of all grounding work, including the materials used, the installation methods, and the test results. These records can be valuable for future maintenance and troubleshooting. Regularly train employees on the importance of grounding and the proper procedures for inspecting and maintaining grounding systems. This training should cover the hazards of improper grounding and the steps that can be taken to prevent electrical accidents. By taking a comprehensive approach to grounding, it is possible to create a safe and reliable electrical system that protects against electrical hazards and ensures the proper operation of the telephone system. This approach should include not only the technical aspects of grounding but also the administrative aspects such as training and record keeping. By paying attention to all of these details, it is possible to create a grounding system that meets the needs of the building and its occupants. And remember, it is always advisable to consult with a qualified electrical engineer or electrician when designing or installing a grounding system. These professionals can provide expert advice and guidance to ensure that the system meets all applicable requirements and provides adequate protection against electrical hazards. They can also help to identify potential problems and recommend solutions. In addition to the above points, it is important to consider the impact of grounding on other electrical systems in the building. For example, the grounding system for the telephone board should be coordinated with the grounding systems for the electrical power system, the fire alarm system, and the low voltage system. This coordination is essential to prevent ground loops and other problems that can cause electrical noise and interference. The NEC provides guidance on the coordination of grounding systems. When installing a grounding system, it is important to use high-quality materials and components. The grounding electrode conductor, the connectors, and the grounding electrode should all be made of materials that are durable and resistant to corrosion. The use of substandard materials can lead to premature failure of the grounding system and increase the risk of electrical hazards. It is also important to ensure that the grounding system is properly tested after it is installed. This testing should include measuring the impedance of the grounding electrode system and verifying that all grounding connections are tight and secure. The test results should be documented and kept on file. Regular inspections and testing of the grounding system should be performed on a periodic basis. The frequency of these inspections should be determined based on the environment in which the grounding system is installed and the criticality of the electrical systems that it protects. Any problems identified during these inspections should be corrected promptly. In addition to the NEC, other standards and guidelines may be relevant to the grounding of telephone boards. These include standards from organizations such as the Institute of Electrical and Electronics Engineers and the Telecommunications Industry Association. It is important to be familiar with these standards and guidelines and to follow them when designing and installing grounding systems. By following these guidelines, we can ensure that the telephone system is properly grounded, protecting against electrical hazards and ensuring safe and reliable operation. Remember that proper grounding is not just a matter of compliance with codes and standards, it is also a matter of safety. A properly grounded electrical system can save lives and prevent injuries. Therefore, it is essential to take grounding seriously and to ensure that all grounding work is performed correctly. The size of the grounding electrode conductor is determined not only by NEC section 250.66, but also 250.166. In general, always refer to the latest adopted NEC edition in your jurisdiction. If you are unsure, please consult with your local building or electrical inspector before proceeding with any work.